Welcome to Math Dog, Episode 5. This episode is most appropriate for intermediate algebra students. It helps you with lessons 612 and 613, but geometers are free to watch also. Might as well get better at solving equations that involve fractions. In lesson 612 on page 408, there's a problem that this is one of your problems. And there's a great dispute among math teachers on how to solve this. Some, like Math Dog, believe you should always clear fractions. Others, like myself, believe that when you have a fraction that's equal to another fraction and nothing else, the easiest way to solve it is by cross multiplying. Here, we multiply 2 times 5 equals 10, and 10 times x, which equals 10x. This one solves pretty easily. X is obviously equal to 1. But again, others will say you should always clear fractions, which I'll show you in a moment. This dispute can get very heated. On guard, Math Dog! On guard! Stand and deliver. Well, I told you it could get a little bit too heated. Don't worry about me, it's just a flesh wound. Also on page 408 is problem 26, which doesn't look like a fraction equal to a fraction, does it? There's this extra piece. But look for shortcuts. We can turn this into a fraction equals a fraction. Look at this clever trick. Subtract 7 from both sides. And notice now you've got 6 over a equals negative 2. Why don't we put that negative 2 over a 1, and voila, we have a fraction equal to a fraction. Now you can cross multiply. When you can't get a fraction equal to a fraction, then you will clear fractions. Next topic on page 408 is problem 28. Now this one, I cannot easily turn this into a fraction equal to a fraction, so I'm going to clear the fractions, get rid of them completely. You've learned this trick earlier this year, this technique. It's not a trick, no, it's a technique. We will find the common denominator, x1 and x, and we'll multiply each of the terms by that common denominator. So here I'm going to multiply by x. Sometimes you need parentheses. Here I'm going to multiply this term times x, and I'm going to multiply this term times x. Let's see, what will that do for me? Well, that will very nicely cancel off these denominators. Hooray! Cancel off those denominators. And when we simplify that mess, we end up with this new equation. Not a new equation, but a simplified version of the one above. Notice that I did multiply 5 times x. That was not a fraction, but it still needed to be multiplied by the same thing as the others. Over here, I distributed my 2. Well, now we've got ourselves a plain old equation. Yes, it's a quadratic equation. So let's see what we'll do here. We'll get everything over on one side and make it all equal to 0. I want to cancel off this 2x, so I subtract 2x. I come over here and I subtract 2x, putting like terms together. And here I want to get rid of this 6, so I subtract it, which means I subtract this 6 over there. Let's see what that's going to give me. It gave me 0 on one side, which is what I wanted. And on the other side, this was kind of nice. The 6's also cancel. So we still have our quadratic equation. We're going to do some factoring. If you're getting ready for a diamond, oh, it's easier than that. we always want to look for the greatest common factor. Look for that first. Let's see here. X goes into each of these two terms, so we can factor that out. Let's see what's left behind. X times x is x squared. X times positive 3 is 3x. Now we've split it, we've factored it, turned it into two things multiplied together to the equals 0. And that allows us to use the zero product property. Either this factor is equal to 0, that's one of our answers perhaps, or maybe this one is equal to 0. That one still needs a little bit of work. So we'll leave the x equals 0 alone. We'll solve this very easy equation. You might solve that in your head. You could write minus 3 on both sides. And we have what looks like two good solutions. Well, two good solutions we don't have. We only have one solution. Why not x equals 0? What's wrong with this solution over here? What am I, chopped liver? Math dog loves chopped liver. Well, let's see here. Why can't we use that? Remember our discussion of domain? You can't let the bottom of a fraction ever equal 0. So you have to take your solutions and substitute them back in mentally and say to yourself, does that give me a 0 in the denominator? If so, I cross it off. The denominator can never equal 0. That's why we cross off this solution and are only left with one good solution. All right, on page 408, problem 38, we have a problem that looks like you could maybe cross multiply, you could clear fractions, but look for shortcuts. Do you notice that the denominators are exactly the same? Well, if that's the case, we can rewrite just whatever's up top and solve that equation, which is pretty straightforward. You subtract 1 from each side, you divide by 2, your answer looks like it's 4. But the real answer is no solution. Why is that? Well, we just talked about that. The denominator cannot equal 0, so you always test this. 4 minus x, 4 minus 4? Well, that's 0, obviously, and we can't allow that to happen. Denominator can never equal 0. So x cannot equal 4. Your answer to this one is no solution. Page 418, the next assignment. Here's a problem that's similar to problems number 5 and 6. They give you an equation written in black, and you're going to clear the fractions by multiplying each of the terms by the lowest common denominator. I've done that here. Now let's see what has happened. The x's canceled, giving you yz. The y's canceled, giving you xz. The z's cancel, giving you xy. So we start off by clearing the fractions. Then you look at the instructions, you say to yourself, well, I want to get the x by itself. So get all of the x terms together. No x's here, leave it be. There's an x, that's going to have to go with this term. So you move those together. Notice how I've grouped all the x terms. All the terms that have an x are on one side. Could be left, could be right. Now, we'll factor that x out. X comes out of here. X times y gives you xy. X comes out of this term. X times negative z gives you minus xz. You factored out the x. Why is that helpful? Because now you can divide both sides by whatever's left over. Y minus z. Divide it away. Divide it away on this side. And you have x all by itself. you've solved for x. Here are two of your homework problems. I'm doing your homework for you. This is on page 418, number 2. The original problem is written in black. You have to solve for h. That means you have to get rid of all this stuff. Oh my gosh. Let's get rid of the fraction first. We've learned how to clear fractions. You multiply both sides by the denominator. So the 3's cancel off, giving you pi r squared h. Now we want to get rid of the pi and the r squared. It's all multiplication. How do you undo multiplication? By dividing. Divide away the pi, divide away the r squared. You've gotten the h by itself. You've solved for h. There's your answer on the other side. That's fairly similar to problem 14. Again on page 418. The original problem in black. We don't want these fractions, do we? So we've done a lot of clearing of fractions today. If you have capital R plus lowercase r, be careful about that. Those would stand for something completely different in this problem. So we would multiply by r plus r on the right, and if we do it on the right to cancel the denominator, we must do it on the left. Math Dog likes this idea. So we now have distributed I times capital R plus I times lowercase r equals E. Well, great if we were solving for E, but we're not. What are we solving for? Oh, lowercase r. That was like that earlier problem. We want to get all of the things that have a lowercase r on one side. All right, that's just this one term. We'll leave it alone, but we'll move everything to the other side. So we'll cancel off the I times capital R by subtracting. And if we cancel it on one side, we have to cancel it on the other side. Subtract it on the other side, I should say. And now we have the lowercase r. There's only one term. It's all by itself. We divide away to undo the multiplication. And we have lowercase r all by itself. And all of this is equal to lowercase r. So again, you'll see this over and over. You eliminate fractions by multiplying by the common denominator. Sometimes it's pretty easy, sometimes a little more complicated. Distribute if you have to. Figure out what you're looking for. Put all those terms by themselves and then divide to get it alone. All right, well done, everyone. Hopefully you'll have success on your homework this week.